Is that fine? Yes. Hi, I'm Anshul Makkar, working as an engineer in Citrix Systems. And today my presentation is about XSM. Thanks, Doug. You gave me a nice platform to proceed on XSM-Flask. So initial part of my conversation, initial part of my talk will cover about basics of XSM-Flask. And then I will go into detail about what are the shortcomings that I noticed in current implementation of XSM-Flask, its design, and why I need to change it or modify it or implement something new that's not there in current implementation. So starting with basic overview. So it's a security framework that is implemented in Zen that enables administrator to get much more finer grained control over how Zen operates or in an environment or how Zen controls its environment. Now in the control in the sense how Zen can control or an administrator can control using XSM domain-to-domain communication, events that are being passed between domains or resources being utilized by domain. So all this is possible through XSM framework. It's based on a MAC model rather than a traditional DAC model where if permissions associated with the user goes wrong, then all the processes associated with that user can exploit those permissions. In this presentation, I will be using these, XSM uses these words, subjects and objects. So I will try to explain what are these subjects and objects. So subject is an entity in an XSM model which requests a permission over an object. So a domain can be a subject, and a resource can be an object. So a subject which requests a permission and an object on which the permission is requested. So for example, domain, a subject, and if a domain requests permission on another domain, then a subject is a domain, object is a domain, and if a domain requests a permission on a resource, then subject is domain, and resource is an object. While in XSM, while we define a policy, while we define a rule, we associate security context with a subject and an object. So if a rule has to be defined for a subject to grant permission to object, we take into consideration security context of subject and a security context of a target. Now, what is this security context? Just for a basic understanding, it can be thought of as a tuple comprised of user, role, and type of a subject. Similar goes for the target also. So if we have to define a permission, you define source security context made up of user, the role that the user performs, and the type of the source, type of the subject. And similar goes for the target, user, role, and type of that target. Now how this security, how we derive the permission, you can think that source security context is one set, target security context is one set, and you do an intersection. And if the result is not null, then yes, permission can be granted. And if the result is void, then no, the permission can't be granted to a subject to perform operation on an object. Now, associated with each security context, now comes a target class. A target class can be thought of as a container that encapsulates permissions associated with a particular entity, associated with a particular subject or an object. Again, I will make myself much more clear with an example. Suppose domain is a class, and all the permissions related to that domain. Here, the permissions means all the hypercalls, domctls, sysctls associated with that domain will come into that class. Resource is a class. All the permissions associated with that resource will come into that class. At the max, 32 permissions can be only 32 permissions can fit into one class because it's represented as a 32-bit int, as a bit mask. So it can have 32 permissions. So now, modifying my earlier statement, if you have to take a decision we consider this class also. So we have a source security context, target security context, and a target class. And then we take the decision. Domain 1 belonging to domain class wants to add or delete a resource to another domain belonging to domain class, and add or delete are the hypercalls that are associated with the resource class. So now this is a third dimension that comes into the picture, which are used in XSM to make a decision.
So what is subject then in this context?
Sorry?
You mentioned subject earlier and objects. Now you mentioned class.
Yes.
And then you mentioned your domain class.
Yes.
Where is subject?
Yeah.
Where is that?
Subject, you can think of it as an abstract term that represents the entities that will request a permission. Like a domain will request a permission to access an object. Now, how the security context comes into picture is that a security context is associated with each subject and an object.
Okay.
Right? So, and target class is the hypercalls that a subject wants to perform in an object, or a source security context wants to perform on a target security context. It can perform only those operations which are there in the target class.
Okay.
Right. So this is how we declare in the code, just to give you a brief in code, how we declare this is the security class Zen1, Zen2, because we have more than 32 hypercalls associated with Zen, so we divide into 2. Similarly goes with domain 3 and domain 4. And this is how we define the bit mask for hypercalls. Zen set time, Zen2 resource operation, set vCPU context, domain create, domain delete. So these are, you call them permissions or you call them hypercalls. This is how we define as a 32-bit bit mask. Now, the architecture. While researching on this topic, I figured out that there were basically 3 aims that were considered while designing this architecture. First is defense in depth, minimal performance impact, and flexibility. Now, how is defense in depth? XSM is basically implementation of hooks. Before a hypercall is executed, there is a diversion in the path, and based on the subject and an object that are subject that is initiated that hypercall on an object, the permissions are checked, and then a decision is made. So there is a deroute in the default implementation of hypercall. So these are basically hooks that have been implemented. As these are hooks, and it will involve extra comparisons, extra conditional statements to check for the permissions. Another major requirement was the performance impact should be minimal. AVC cache, I will go into detail about that in the next slide. So this was AVC cache was introduced to minimize the performance impact. And third thing was flexibility. How this was flexibility, how XSM ensures flexibility. In XSM, you can consider 2 major components are involved. There are more also, but 2 major components. One at the upper level you can think of as an object manager, which requests permission. And at the bottom level, we have a security server or the decision-making machinery that gives the permission. So these 2 are independent and they are segregated. Based on your requirement, you can change the object manager or the policy enforcement logic, and the decision-making machinery, decision-making, or the security server, decision-making entity can modify the results based on the change in the policy. So these 2 are independent. You don't need to worry about the security server or the decision-making machinery. It's separate from the policy enforcement logic. Some of the other components that are involved in XSM security, policy. At present, it's a big monolithic block of one single big policy. We define set of rules which governs the decision. And how the rules are defined, it's allow, domain belonging to DOM0 type, to execute these hypercalls, set vCPU context, max vCPU, or set domain max mem belonging to target class domain on another domain belonging to DOM U type. Second instance, domain belonging to DOM 0 type should be allowed to add or remove resources that belong to target class resource to domain belonging to DOM U type. And I have talked about policy controlling entity. That's a broad level that requests permission. Then a security server, it's a centralized point where all the decisions are made. And the security server refers to how the security server makes its decision. It refers to the policy DB, which is maintained by the security server. We have a policy that's compiled into a binary format, and then it's loaded, and internally it's saved into policy DB, and the security server refers that policy DB to makes its decisions. So with all these things, what we try to answer is that whether X can do Y on Z or not. This is just a pictorial representation of how this happens. This is a client, then we have policy enforcement logic, and then we have a security server, which uses policy DB to make its decision. Simple how the decision-making control flow. Access rules defined in a policy. Domain created with appropriate security label. This is another important point, as I mentioned about security context. So each domain that's created should have an appropriate security label, which is the source context or the target context based on how this happens, how the subject or object is being used. So every subject or an object or every domain or a resource has to be created with a label. Then only the XSM will be able to take decision. If it has not been labeled, then it will be categorized as unlabeled, and its access will be blocked by default. That's what the policy says. So domains are created with appropriate security label. Policy compiled and loaded by tool stack. We use XC load policy. Access made, permission is requested. AVC is checked. AVC is the cache. Oh yeah, I missed this AVC cache component. So to improve the performance, we always don't have to go to the security server to make the decision. Once the security is, if a permission is requested, then first we check this AVC, and if it's a cache hit, the decision is returned from this AVC, and if it's a cache miss, then we go to the security server. Decision is made, results are cached, and then returned back. So this is the AVC cache. This is how XSM takes care of improving the performance. So access rules are defined, domain created with appropriate security label, policy compiled and loaded into policy DB, access made, permission requested, AVC is checked, if cache hit, return the access decision, if cache miss, consult security server. Security server takes a policy decision in consultation with policy DB, results returned to the requester, and the result is cached in the AVC for future references. Just to make things clear, how this table or the policy DB will look like. So you can think of it as a two-dimensional table where subjects are running down the left edge and objects are running down on the top row. So we have DOM 0 with source security identifier or source security context can create DOM U with target security identifier or target security context of 5. DOM U of source security identifier 3 can access resource or an object with target security identifier of 4. So it's a table which security server takes into consideration while making decisions. And what is a security identifier? This is another question that can come to your mind. So internally, security server doesn't recognize security context. It maps each security context to an independent or a unique security identifier. That's SSID. That's SID. Again, a picture representation. Domain created with security label. Goes to policy enforcement code. It requests access. Query permissions from AVC. If it's a cache hit, return answer. If it's a cache miss, go to the security policy, return the permissions, and a bit of code how these are internally implemented. We generate, for some of the basic entities, we generate initial SIDs to start with. DOM0, this is how SID DOM0 gen context, DOM-U gen context, then class Zen, which I explained earlier. Now this is important. Hooks, Flask, domain create. Just to give you an example, as I mentioned, XSM is basically XSM implements hooks. So what happens is that suppose Zappy or the tool stack wants to create a domain. It issues a create domain hypercall or a priv command that goes to Zen. Now before Zen executes that hypercall to create a domain, what it will do is there is a deroute, and this from hypercall, before implementation of hypercall, this function is called Flask domain create, and it checks AVC current has permission, whether the source has permission to perform domain create operation on target object. So this permission is checked, and if the security server returns an answer yes, or AVC returns an answer yes, then this operation is allowed, and domain is created. These are some of the interface files or the configuration files that we use. For each module, we have a separate configuration files. DOM0, we can define independent rules for DOM0, DOM-U, NIC, independent resources, IMM, NIC. For each subject or object, we can define an independent configuration of rules, which will be compiled in a one big policy configuration file. Now comes the problem statement, which led me to work on some modifications in the present architecture. Now, in the present architecture, all the rules, all the policies has to be associated with the type, which is a general broad criteria, general broad categorization of objects and subjects. Like if a rule has to be formed, it will be for all the objects or subject associated with that type. There is no specialization. Suppose if I just to give an example, if there is a broad level category, introspection domain type, and we have two domains, intro1 and intro2. And if the introspection domain type says that it's allowed to introspect other domains, it's allowed PCI access, it's allowed access to resources. Now, if intro2 doesn't want access to PCI resources, it will still be allowed. It will still be given access permissions to do PCI pass-through, to access a PCI device, because it belongs to introspection domain type. As Doug mentioned, that we need to be restrictive. If there is no need to grant the permission to a specific domain if it doesn't require. That's where I find this to be too general. And there is no scope to be specific. It has to be based on type. Now, to solve this problem, I read about we can use two approaches. Either we define a separate type based on specific set of requirements. So we have our introspection domain type 1 to do this, introspection domain type 2 to do this, to introspection domain type 3 to do this. Or we duplicate permissions for each domain. But both these approaches will lead to more complexity, more complex XSM hooks, and reduce flexibility. So now what I'm proposing is that be restrictive and be specific. And second is flexible policy. In be restrictive and be specific, I will come into the detail of flexible policy later. So in be restrictive and be flexible, what I'm trying to introduce is that there should be a possibility to introduce a subset of the umbrella policy. So we have an umbrella policy, introspection domain type or resource sharing type. But there should be a possibility that I'm trying to create that will allow me to create a subset of that policy for a particular domain. And it will be subset of that umbrella policy. It won't go beyond that. So just to give an example, we have an umbrella policy where a domain belonging to DOM U type is allowed to add resources to another domain belonging to DOM U type, add and delete resources. But I want a domain which should only be allowed to add a resource, not delete a resource. So within this, I can formulate a subset of that policy which will be restrictive. I have an introspection domain which should be allowed only to access IOM resources, not to gain access to PCI. So I can have a subset within that umbrella policy. So the umbrella policy can be broad. Within that, I can have a subset of that policy which is more specific, which can be more specific, which can be specific to a particular domain. Now, to implement this, there are some set of prerequisites that needs to be fulfilled. First is that what I am proposing is that security policy should not be based on subject and object. It should be based on requirements. And we can have multiple security policies. Not necessarily all the policies are loaded, but we can have a specialized security policy for introspection domain that will do only PCI pass-through, or for a resource sharing domain, resource sharing use, which will use the resources. So we can have specific set of policy based on the requirement rather than subjects and objects. Now, with this implementation, it will also necessitate that it should be able to dynamically load and unload the policy. At present, what happens is if we have to load a policy, we need to compile it and then load it at boot time or after boot. Now, if you want to change something in that, again, we have to compile it and load it. So what I'm proposing is that the policy should be dynamically loadable and dynamically modifiable, and permissions should be granted or revoked at runtime. There should not be any need to recompile the policy again and again. Once a policy is loaded, it should be dynamically modifiable and dynamically loadable. Sorry? Why? Yes. Because in the present architecture, we can't modify, every time it has to be compiled or loaded, and loaded again. Now, if we are going into an architecture where you have specific set of policy catering to specific set of requirements. Now, a domain right now requires a certain access to a certain resource. Maybe in future, it doesn't require an access. So it should be possible to dynamically change the policy instead of every time compiling and loading it. And we will have specific set of policies for a specific set of requirements. So the other policies will not be impacted by changing this. That's what we aim for. So what are the challenges in this approach? It's easy to say that we can dynamically load and unload or revoke and grant privileges, but how to ensure the atomicity? There may be a policy is already loaded in the system. There are certain operations, there are many operations that are using that policy. So what will happen those policy if I dynamically change the policy or dynamically revoke permissions or add more permissions? So atomicity has to be ensured so that the new rules overrules the previous changes or the previous rules that are already there. What happens if a certain operation is going on which is using the current policy, and if in between if I revoke the policy? So what happens to all those kind of operations? And just imagine how this problem will escalate in distributed environment. So all these challenges I'm trying to address with my I will float the design doc and for comments. So all these challenges I'm trying to address. And with 3 minutes left, what is the high-level approach that I have thought of and what I'm trying to implement? So with each domain, I am trying to introduce a unique identifier, which will be included right from the stage the domain is created, along with security label. So this UUID, or the unique identifier, will be a part of security label. And it will percolate down right to the point security server takes its decision. So So while the security server takes its decision, it has to consider the UUID, unique identifier associated with that domain, and it needs to think whether there is a subset of the umbrella policy specific to that domain or not. Now, when I load the policy, along with security identifier, source security identifier, I will have source UUID. Along with target security identifier, I will have target security, target UUID, and then target class and restrict. So this unique identifier for a domain will allow me to restrict the policy, to restrict the rules for a specific type of domain. For a specific, not a specific type of domain, but to a specific domain. And be more specific and be more restrictive. Yeah. I think that's up. Thank you. Now, questions?
So when are you going to post a design doc?
Yeah. Maybe 1 week or 2 weeks down the line.
All right.
Yeah. I will post the design docs for the same. Design doc, or it will be basically an RFC. Nothing is finalized, so it will be request for comments. It will not be a design doc. Yeah.